C1 Quadratics exam question, January 2009, question 7. The equation kx squared plus 4x plus 5 minus k equals 0, where k is a constant, has two different real solutions for x. So reading that first bit of the question, let's underline any key information we're told. So we've got two real solutions. That tells us our discriminant, b squared minus 4ac, has got to be greater than 0 if there's two real solutions or two distinct roots. Our discriminant is greater than 0. So we're going to need that in part A, because we need to show that k satisfies this inequality. So we're going to use our discriminant, so we need to write down our values of a, b and c. So a is the coefficient of x squared, which is k. B is the coefficient of x, which is 4. And c is our constant, which is 5 minus k. So let's substitute those into our discriminant. We've got 4 squared minus 4 multiplied by k multiplied by 5 minus k. That's greater than 0. We've got 16 minus 4k multiplied by 5 minus k is greater than 0. Just got to expand the bracket. 16 minus 4k times 5 is minus 20k. Minus 4k multiplied by minus k, it's going to become positive 4k squared. That's greater than 0. Right, can we simplify any further? So we can divide through by 4. So 16 divided by 4, got 4. Minus 20 divided by 4 is minus 5. And 4k squared divided by 4 is k squared. Now we just need to reorder that, and then we've proved what it asked for in part A. So we've got k squared at the front, minus 5k plus 4 is greater than 0. That's what we wanted to show. In part B, we need to find the set of possible values for k. So if we use what we've got in part A, k squared minus 5k plus 4 is greater than 0. Let's have a look back at the question again. If you ever see the word hence, you're usually using a link, or you're following on from part A. So you're using something that you've already simplified or worked out in part A. So rather than using all this, we've simplified it to k squared minus 5k plus 4 is greater than 0. So we're using that from part A. So we need to factorise. K multiplied by k will give us the k squared. 4 and 1. And we need minus 5k, so they both need to be negative. So we've got minus 4k minus k to get minus 5k. And our minus 4 multiplied by minus 1 will give us the plus 4 at the end. So our roots are k is 4 and k is 1. Now you must always sketch a graph when it's a quadratic inequality. If that was just an equals sign, then our solutions would just be 4 and 1. But we want to know where that graph, or what values of k are greater than 0. So let's mark on our roots. We've got k is 1, k is 4. It's a positive parabola. Now we want greater than 0, so we're shading the region of the graph above the x-axis. So that tells us we want these two separate inequalities. So we want k values that are greater than 4. K needs to be greater than 4. We want k values that are less than -1. Sorry, less than 1. So the question, if you look at the number of marks, it's 4 marks for part B. If you simply just did this bit and worked out your roots, k is 4 and k is 1, you're only going to get half the marks. You must always sketch the graph when you've got a quadratic inequality and shade the correct region for the extra 2 marks.